Hey everyone, welcome. We're going to look at our first sort of kind of specific um, quadrilateral today. We're going to look at the rhombus. Okay, so a rhombus um, has quite a few properties, kind of like a parallelogram, but it's a little more specific. Um, the one thing about a rhombus that's different than a parallelogram is that all four sides are equal, right? So think of a square that's able to be tilted, right? A square technically falls under the category of a rhombus as well. But there we go, right? So we see that's true, right? Opposite sides are parallel, just like a parallelogram as well, right? So you see those indicators, right? If you're not sure what I'm talking about, go back and look at the video from the previous lesson where we talk about parallelograms. Just like parallelograms, opposite sides are also equal, right? So we can see those indicators here as well. So that's something that we know. Um, Diagonals are perpendicular bisectors, right? So not only like with a parallel or with parallelograms, they were bisectors. They're also perpendicular to each other. So you're going to see right angles in the middle. This is important because it also tells us something else that's not included on this list, and that is that the angles that the diagonal cuts into, those are actually bisected also, right? So we're going to see the same measurement on either side of the diagonals. Okay, so that's another indicator of a rhombus that's different than a parallelogram. Parallelograms don't have to have that happen, but a rhombus does because of the even nature of their sides. And then, of course, just like before with a parallelogram, we see, come on, let me pick this, that adjacent angles are supplementary, right? So we know that, the bigger the angle one side has, the smaller the other one does as they balance with 180. So again, like yesterday, I can, or like the other lesson, I can put a little bit of information in, and the rest of it should um, come out here, right? So if I make, let's say, for instance, I'm going to make this side to be 8, okay? We'll make this side equal to 8. I'm going to make this side, and again, this isn't perfect, so, um, you know, give me a little bit of a break here. We'll make this 5, okay? And we're going to make this angle here, okay? We're going to make this angle here. We'll make this 4, and we'll make this angle here 80 degrees. Okay, right? So if I know that that's true, what else do I also know? And I can fill in the rest of this. I'm gonna go back, I'm gonna pick red again. So the first thing I also know is that every angle in the middle is a right angle. Okay, so those are all 90 degrees. I know that automatically because that is in the nature of what a rhombus is. Um, I know that we're also gonna have our side lengths are all going to be 8. Okay, this is an important part. Okay. Now, again, these are just some kind of made up numbers, right? So don't hold me too much to account for this. But if we know these measurements, we know that this should also work as well. Again, this isn't going to be perfect here. Um, the We also are going to know, again, this is 5 and this is 4. Again, this is not a real rhombus. I'm just showing you how I can copy information around. So as far as the angles go, I know that overall this is going to have to be 100, right? Because again, adjacent angles need to be supplements of each other. We'll do 100, do 100. Or this will be, sorry, I'm daydreaming. This is 80 and this one's 100. But on top of this also, and I'm going to do this in a different color, I know that the halves, like these little bisected angles, these are going to be half of the regular size, the overall size. So those are 40s. These are 50-degree angles, and so on. And I can copy this around, okay? So again, a little bit more information about some of the parts of this shape, especially um, when we're asked about these extra part of these angles. But again, just based off of a few numbers, if they give us, we can copy that around. Now, again, This is just, I just threw out some numbers that looked fairly close. This is not actually the measurements of an actual rhombus because, again, there's some other properties of geometry that we can prove that that's not true. But again, if we know that these are true, that we can move along with it. So let's look at these and determine, are we able to determine if a parallelogram is a rhombus or not based on the information that they give us? So I'm going to go to red here. The only information I see here is that this is an 86-degree angle. This is not consistent with what a rhombus is at all. Remember that rhombuses are rhombi, whatever. They have to have 90-degree angles at the intersection of their diagonals in the middle. So the fact that this is 86 is not going to it's telling us this definitely isn't a rhombus. Okay, so let's check this out. So if we have a quadrilateral right here, right? If they tell us this is a rhombus, right? So we know that that has to be one. So that tells us all those properties we just talked about. Um, the measurement of QSR, right? So QSR, so this angle here is 2V. So what is the value of V? Okay, so how do I go about this? Well, I know that adjacent angles here, so angle S and angle R, that these two angles have to be supplements of each other. They have to add up together, right? So the measurement of angle R is 128. The measurement of angle S, therefore, is going to have to be 52. Okay, 52, because they together should make 180. Now, again, you can subtract to find that, but that's the rule, right? They have to add up to be that. So if I know that angle S is 52, right, then that means that the measurement of angle of QR of QSR, excuse me. So again, QSR, this half of it is going to be half of 52. It's going to be 52 over 2, which is 26 degrees. Okay, so again, each angle is bisected by its diagonal. Okay, and as we move along, can we determine, is this parallelogram, is this a rhombus, right? Can we tell this or not? Well, when we look here, I see that the only information that I have are about the angles themselves. I don't see anything about the side links, but what I see here is that each angle, it's split, and we see a single arc on each side. So you see the single arc here, and here, that's an indicator that this is 63 degrees as well. This is very much what we would expect from a rhombus, right? We would see those angles be cut in half, and in fact, if they are cut in half, then that's the sign of a rhombus. Last example we'll do, and then we'll move on. How can we again use some of this information to figure this out? So we're given this angle here, SUV, is 55. So we know that this angle over here is also that, which means overall, right, we have a 110-degree angle. All right, so that's important, right? So again, we know just by knowing that part, we know that the other part's equal, and together they make a bigger angle together. So they're asking us what STW is. So STW is this angle down here. So just like the last problem, we are going to find the, we're going to say that, if the measurement of angle U is 110, then that means the measurement of angle T has to be 70, right? So again, it has to be the supplement here, and then we're going to take this, and so the measurement of angle STW, again, that's this STW is half of angle T, so it's going to be 70 over 2, which is 35 degrees.